In this video, I want to go over how to do some exponential growth rate problems. Now, we have this general equation, and you'll see different equations used. I find this one definitely the easiest. Okay, let's go through what each value means here. So n is the amount after t. So that means that this n is related to this t value. Okay, so after a given amount of time, this is what we have at the moment. NO is the initial amount. So what did you start with? Okay, then we have G, which is our growth amount. Okay, and our growth amount is related to our percent increase. So sometimes you see this G represented as 1 plus R, and R is the percent increase. So if you have a 5% increase, that means R will equal 0.05. If you have a 15% increase, that means you have an R of 0.15. Okay, remember, anytime you're working with percent, it has to be represented as a decimal. Now, TG is the growth rate. So what is the time it takes for you to increase by G? That's what that means. Okay, so these two values are related. Now, the last thing to mention here is TG and T have to be in the same units. Must be same units. That's super important. Okay, so let's move on here. Let's do an example. So a population of 100,000 people is growing at a rate of 5% per year. Determine an equation that can model the population growth over time t in years. So recognize this is what we're starting with. That's your initial amount. NO is 100,000. Now you're increasing, so this is your percent increase every year by 5%. So R is going to equal 0.05 because remember that represents 5%. Okay, and how do I get that? Well, anytime you want to change a percent to a decimal, you divide by 1,000. Okay, so that's your R value there. Now remember that growth rate is related to this. So every year, so T is 1 year, we increase by 0.05%. So here, the TG, so the growth rate is every year. So every 1 year, and you can also represent it by every 12 months because that's how long it takes, right? Now I want to figure out what G is here. G again is 1 plus R, so G will be 1 plus R, and remember our percent increase is 0.05%. So G is going to be 1.05. Now I have everything I need to plug into my equation. So N equals 100,000 times 1.05 to the power of T over 1.05, not 1.05, but over just 1 year. Okay, so there is our equation where we can figure out and plug in T years to figure out what it has grown to. Now, if you go below, B is going to say, what is the population after 30 months? Okay, so recognize T equals 30 months. It wants to know the N value. So remember, we have T here, which is 30 months, and it wants to know what remains after 30 months, or how much has it grown to. The problem with using this equation is that it's in years. So you either need to convert 30 months into years, or I can change this equation to be used in months, which actually that's what I'm going to do. So this will all be the same thing, except that I can write 1 year, I can represent that as 12 months. So this is going to be 12 months. And now I have an equation where if I'm given a question where there's months, I can plug that in. So let's do that. I can use this equation now, and I can happily just plug in t 30 months in for t. So the number of the number of people after 30 months, I can plug in there. And we can put that into our calculator. So we have, let's clear all that, 100,000. Let's make sure that's 100,000. Yep. Multiplied by 1.05 to the power, okay, and remember your power button is found right here, okay, to the power of 30 dividing 12. And we are going to increase now to 112,972 people, okay? And I will keep it at 172 people because you can't round up to 3. That doesn't really make sense in terms of it being people, so we're just going to round it to the nearest person, but keep it at 2. Okay? Now, on to our next problem here. How many years pass to reach a population of 125,000? So here, it's asking if your n value is 125,000, how long does that take? So this time, we're given n, and we have to find t. It wants to know in years, so I'm going to use this equation. If it wanted to know the amount of months, I would use this equation. So here, let's use our year. So again, n equals 100,000 times 1.05 to the power of t over 1 year. And now I can plug these in. So here I will have, n is 125,000 equals 100,000 times 1.05. And I can represent this simply as t because t over 1 is obviously just t. Now I'm going to just start solving for t. So I'm going to divide by 1,000, divide by 1,000, and that will give us, I think it's 1.25, but let's just maybe make sure here. So 125,000 divided by 100,000 gives us 1.25. That equals 1.05 t. Now, we haven't quite learned how to deal with this yet. That's something we will learn in logarithms to solve for t here. So the only way we know how to actually solve for this is using our calculator. So I'm going to put y1 equals 1.25. I'll put y2 equaling 1.05, and I'm going to plug that into my calculator. So I'm going to put y equals, I'm going to clear everything I have right now. And again, my y1 is 1.25. I'm going to go down to y2, and I'm going to put in, this is the power of t. I'll put in 1.05, and that's going to be to the power of, and in this case, I'll use x since it's in my calculator. I'm going to hit graph, okay, and I'm going to look at the graph, and now I'm just looking for those intersection points. You're going to have to play with the with your view function, so your Windows function, and then again, you're going to press intersect. So you would press calculate. Sorry about that. You would press your calculate function, and you would find the intersect. Okay, I don't really have that ability on here, but make sure you press second calc on your calculator, and then press intersect. Okay, and we've gone through that in another video before this. But you would find that intersection point, and you're going to find the intersection point to be at x equaling 4.57. So t here equals 4.57. So it looks like after 4.5 years, that's when you reach 125,000 population. So there's your solution there. Okay, so if you don't remember how to calculate intersection points, you gotta come talk to your teacher, or you watch the video listed to do that. Awesome. So let's move on. Let's just go over one more example here. No, I guess two. But these are some really important terms you need to know. Like the word annually means that happens yearly. Semi-annually or biannually, that's twice a year. Quarterly is every 3 months, and then these two confuse the heck out of everyone. Bi-weekly means it's every 2 weeks. Okay, so if you get paid bi-weekly, you get paid, say, every Monday. Okay, that means you only would get paid, or that means you get paid 26 times a year. Some people get paid bi-monthly, so twice a month. Those are two different things. Sometimes there's 3 Mondays, or sorry, not 3 Mondays, but sometimes you have, you get paid 3 times in a month if you get paid bi-weekly, whereas here, you will always get paid twice a month. And that is because, in this case, that means you would get paid like on the 1st and the 15th, okay? And you would get paid less amount of times. That would be 24 times a year. So those are two important very things to kind of distinguish between. So let's look at example 2. If you put $500 into an investment that is projected to increase 1.3% every quarter, determine the general equation of this investment. Give two equations where one uses months and the other uses years. So this is every quarter. So what does every quarter mean? Well, that's every 3 months, right? It's a quarter of a year. So if I took 12 months and I divided that by 4, because that's what doing a quarter is, that would give you 3 months. So here, if we talk about our equation above, our growth rate, TG, is going to be 3 months. So let's write that down. TG will equal 3 months. Now, in this case, this is my growth increase. So this is R, okay? And remember, you would have to put that into a decimal. So I'm going to divide it by 100%, and you're going to get 0.013. So this is 0.013. So at this point, R equals 0.013. So that means your growth amount is going to be 1 plus that number to give you 1.013. Okay. Now, what was your original value? Well, you originally put $500 in. Okay. And now from there, we can pretty much plug all these values in. Okay, so here will be your original amount, your growth amount during the time, and the growth rate. So it'll be N, and your initial amount is $500 times 1.013 to the power of T over 3 months. So this is your general equation for months. How can we use it representing years? So recognize this is 1 year split into quarters, so 1 over 4. So this will be 1/4. So if we wanted to use years here, it would be N equals 500 times 1.013 to the power of T over 1 over 4 year, okay, because it's a quarter of a year. Now remember, focusing here, dividing a fraction, you multiply by the reciprocal. So T over 4, or sorry, not T, that'd be 1 over 4. So let's change that. Sorry, let's quickly erase that. Should be 1 over 4. You're dividing a fraction, so you multiply by the reciprocal, so 4 over 1. So that'll be 4t. So it looks like I flipped this, and I'll put it as 500 and then 1.013, and this will be 4t, where in this case, t is in years. So this equation is for if you're using years, which makes sense because 1 year, if you plug in 1 there, well, that's 4 quarters. So you will increase 4 times here. Now, after 10 years, how much is your investment worth? Well, here I'm dealing with years, so I'm going to use this equation. This equation is in months. So here, n equals 500 times 1.013 to the power of 4 times 10 years. Now that will be 500 times 1.013 to the power of 40, right? 4 times 10 is 40. Now what does that 40 represent? 40 actually represents 40 months. Okay, so that's something to kind of mull in your brain there. So we will go, let's bring out our calculator. Let's clear this, okay? So 500 times 1.013 to the power of 40. So 4 years, that will give me $838. So we didn't increase very much. This investment is okay, but as you go along, that'll increase by quite an amount. Okay. Now, hopefully that helped. Let's go on to example 3 here. So example 3, a bacteria initially starts at a cell population of 400. After 7 weeks, there are 10,000 cells counted. Determine the biweekly percent growth rate for this particular bacteria. Okay, so first of all, what does biweekly mean? Biweekly means every 2 weeks. Okay, so let's note some things. Well, our initial amount is 400. After 7 weeks, there's 10,000 cells. So there, N equals 10,000 when T would equal 7 weeks. See, that's important to distinguish. Remember, N is related to the amount that's passed, not the growth rate. So this is 7, this is N. And then here, it wants us to determine the biweekly percent growth rate for this particular bacteria. So biweekly is every 2 weeks. So it wants us to figure out if the growth rate is every 2 weeks, what is G? Okay, so N equals NO times G to the power of T over the growth rate. Now we can just plug our values in. So 10,000 equals 400. We're looking for G here. And this would be 7 dividing 2. Okay, now we can do some mathematics. So divide 400. 10,000 divided by 400. Let's get that open here. So 10,000 divided by 400 gives me 25. That equals G to the power 7 over 2. Now, how do I get rid of this 7 over 2? Well, this is some exponential laws that you should have watched at this point. And I can use some exponential laws to solve this. So what I'm going to do is I'm going to put the power of 2 over 7. So I'm kind of canceling that out. And what you do to one side, you do to the other, 2 over 7. Because remember, if you have a number to the power and that thing's being to the power of, then you simply take the exponents and multiply them together. So you would multiply these two numbers together since they're the power of a power. 7 over 7 cancels out, 2 over 2 cancels out, so you're left with G. And then on this side here, you do 25 to the power of 2 over 7. So how do I plug that in my calculator? I'm going to press 25 to the power of. Some of your calculators don't put your exponent in like this. It'll just have a little arrow. If that's the case, press brackets and bracket this. 2 over 7, and then close those brackets. So you can see that now. And that's going to give us 2.5084. Now, recognize this is the growth amount, but it wants us to find the growth rate or the percent growth rate. So how much are you growing every 2 weeks? In order to figure that out, remember that G equals 1 plus R, where R is the percent increase. So let's figure that out. So 2.508 equals 1 plus R. So I'm going to subtract 1 and subtract 1. And I'm going to get 1.508 equals R. So this is the decimal, so I'm going to have to multiply this by 100 to get to a percent. So I'm going to take 1.508 and multiply by 100%. And that's going to give me 151. I'm going to round it, okay? Or, yeah, 150. Let's just put 0.8 for now, and I'm going to round it to 151%. So that means every 2 weeks, this bacteria grows by 151%, which is a huge amount, okay? So it looks like it's growing quite a bit. So if this bacteria is deadly, that's not a very good thing, okay? So hopefully these examples kind of helped clarify some things.